Hi guys, this is Rohit here, and today we are going to be talking about something called clustering. And frankly, this is probably the only lecture where we're going to talk at length about unsupervised learning. So all this while, I think the last lecture where we were talking about imbalanced data, we were talking about supervised learning, right? So there was always this particular thing that there was a trained data, and that trained data had a target that you kind of wanted to you wanted to predict, and the target was housing price in case of regression problem. That was basically whether the customer should be given a bank loan or not in case of classification problem. So supervised learning was always where we had this particular thing called X, which was our training data, which was our features, and then we had a Y, which was basically could be a continuous or discrete thing, and Y was basically our target. So given an X, we wanted to predict how Y would look, and that was a whole paradigm of paradigm of supervised learning. So today onwards, what we are talking is something which is slightly different from that, and in a lot of ways quite a lot different from supervised learning. So today we are going to be talking about clustering. Clustering as such is one of the applications of unsupervised learning, and probably one of the most used cases of unsupervised learning. But given that aside, don't get kind of worried about what we are going to do right now. We are going to basically just try doing a lot of things just with the X data. That's the concept right now, right? So earlier we had a Y and we had an X, and we were training our algorithm such that it could learn to predict Y given an X. But right now what we are going to do is basically we are going to be given just the X values, right? Just the features, and from those we are going to try and kind of make sense out of those features. That's the whole goal of unsupervised learning. So no more Ys, no more target variables, nothing of that sort. So that's it. So that's the agenda for the day. So we have an introduction to clustering, which is going to be a short session. Then we are going to talk a lot about k-means clustering, and then there's something called hierarchical clustering. So we are going to talk in detail about both of those techniques, and then we are going to see how that is kind of implemented in case of Python. So basically using scikit or any other library that is. So that's the agenda for the day. We are going to first get introduced to clustering. So unsupervised learning, so that's the concept I have already explained to you, which is basically that you have X and you just have only X. That's it. No more Y, no more target variable, nothing of that sort. You have just got X, and that's the only thing that we are going to use and make sense out of. So some applications of unsupervised learning before we kind of just talk about clustering as such. So before clustering, there's one major application of unsupervised learning, which is in case of dimensionality reductions. So what is this dimensionality reduction? So first, to understand what is that use case and particularly what is the concept behind dimensionality reduction, first probably, I don't know if you have been kind of familiar with this concept of called curves of dimensionality. Curves of dimensionality is basically this problem where if you have your data, if your number of features are extremely high, say you have got 1000 features, 2000 features or 3000 features, then probably making sense out of that kind of a data could be extremely tough. So that's why we use techniques to kind of so we use basically techniques so that this 2000 dimension or 2000 dimension data can be reduced down to say 100 dimension or 20 dimension data, keeping the semantics of the underlying distribution same. So basically, say to kind of give you a more concrete example, let's say compare the case of Netflix, right? So Netflix is basically the place where basically you have movies and you have users who have rated those movies. So there could be so many movies, right? Obviously, if you go on Netflix, you see so many of those movies. Now to build anything on top of that, right? Anything we want to do, supervised, unsupervised, whatever, it's extremely tough, right? So it's incredibly tough to kind of deal with data which is say 5,000, 50,000 features long, right? So what you want to do is basically somehow reduce that data into a much lower dimension. So instead of having 50,000 columns, you probably want to just have 10, 20 or probably 50, 100 odd columns. So how do you do that? In case of Netflix, it's much more easier to kind of get the idea. The idea in case of Netflix is basically you have these movies, and you can kind of, based on how users have rated this, you can kind of probably make some sense of which genre of a movie, because see, if movies are basically, if one user is basically liking similar kind of movies, you can probably guess that all those movies belong to the same genre. And then if an user is basically disliking all movies, movies which are giving a rating to say 3 to all of some movies, then you know that all those movies which are being given a rating of 3 by one particular user, probably those are all belonging to the same genre, right? So depending on how users are interacting with movies, you can basically kind of make sense that probably these all movies belong to the same genre, and this is a different group of movies which belong to the same genre. So the concept of genre, kind of a genre or concept, or however, whatever you want to call it, so that's the concept that you use in dimensionality reductions. We have a lot of dimensions, and you somehow want to keep the inherent meaning of the data set same. So basically the way users have rated, right? So basically you see users have rated one particular genre very highly. So instead of having all the movies from that genre as individual columns, you basically collapse that down and just represent during one particular feature, which is the genre of all those movies which have been rated highly, and replace that with one rating for that particular genre for that user, right? So that's the concept. So you have got multiple movies, and you cannot really do a meaningful computation using all of those. Those are extremely sparse matrices. So what you do is compress them such that you can have non-sparse matrices, dense matrices, and more importantly, what you can also do is basically, all your machine learning algorithms you can run very efficiently without kind of having to run into the problem of curse of dimensionality. So that's the problem of unsupervised learning that's the first problem, which is the dimensionality reduction problem. Now the second problem, that's called density estimation, right? So this is something, again, you have probably been familiar, sort of, you have seen this in EDA, right, where we saw kernel density functions, right? So kernel density functions are basically nothing but this concept, right? So I'll explain you this. So you have got this diagram. So this is, say, the histogram, right, of one particular say this is a distribution histogram of prices in a particular locality or in a particular city. So this is a histogram. This is a discrete data, right? So this data is discrete, which says between this price to this price there are so many houses, between this price to this price there are so many houses. Now what do you want to know? What is the exact number of houses at any given particular price, right? So at given any particular price, what is the number of houses that you can expect? So to do that, what you use is, instead of using a discrete distribution, you kind of map a continuous distribution on top of it, and from that you can easily figure out, given any price point, what is the so given this price point, what is the corresponding number of houses that you can expect at that price point. So this was a discrete distribution that was there earlier, the histogram distribution, and from there you convert it into a continuous distribution. That is this process where you use how you fit this basically there's a underlying normal distribution or whatever, it could be not be normal, any distribution that you fit in on top of this. That is the whole idea of kernel density estimation, and that's something that you have again is basically an application of unsupervised machine learning. And now the final thing which we are going to focus on this particular lecture, which is the concept of clustering. So clustering is this concept where all you're concerned about in clustering is basically, you have got, say, 10,000 data points, right? This could be 10,000 data points about house prices. Earlier, when we were doing supervised learning, we basically have the houses, their features, and then the price they were kind of sold at, and based on that we were trying to kind of predict the houses. So in this case, we are not going to try and predict the prices, because the price column itself won't be there. We would still have the features about house, and what we are going to concerned about is basically separating those houses into different buckets depending on their features, such that prices of houses which are of high value should be one cluster, prices of medium value should be one cluster, prices of lower value should be one cluster. Similarly, in case of bank loan giving example, right, in earlier cases we were basically given features about the person who was applying to the bank for loan, and we were basically having the Y value, whether the person was actually approved a loan or not, and then we were trying to classify for any given new applicant whether he should be given a loan or not. Now in this case, unsupervised machine learning, that's something that completely changes, because we don't have any more status about whether they would be given loan or not. We have the data about the applicants, we have their income, salary, and all of those things, education, and all of that we had talked about in the lecture. So we have all those details, but we do not have anymore whether they would be given a loan or not. So in unsupervised learning, when we are doing clustering, we are basically trying to again separate them into two groups, such as one group consists of people who have been given a loan and people who have not been given a loan. So in clustering, the idea is that you have your data set and you somehow separate them into different clusters, such that each clusters basically represent people who are of very similar nature. People or whatever items which are of very similar nature, and then the other groups are basically items of very similar nature. So they kind of divide your data set into different clusters. Each cluster consists of items which are very similar to each other, right? And the idea is that between two items from different groups, they would be probably very dissimilar to each other. Items from same groups, they would be very similar to each other. Items from different groups, they would be dissimilar to each other. And that's the whole concept of clustering. You have your data set, split that into multiple parts such that each part consists of items which are extremely similar to each other, right? Item, people, whatever. That's the idea of clustering. So that's obviously that sounds easy, right? That's not something which is very difficult. So basically all you have got to do is for every point basically see what for every item, see which are the items which are similar to it, put them in the same bracket, and then kind of just do that for all the items. That's pretty simple, right? It doesn't sound very tough. So that's actually what it is. It's not very tough. Today's lecture is definitely one of the most easiest lectures that you would probably see. So clustering is very simple a concept. There's nothing, no more of those gradient descent, no more of those decision tree fitting, nothing of that. So very simple concepts that we are going to talk about. So we are just concerned about basically measuring similarity, and basically once we measure similarity, items which are very similar fall in one bucket, items which are not similar fall in another bucket. So I already have told you clustering is basically this concept where you kind of have clusters which have got very high intra-cluster similarity, which is basically items within one clusters are extremely similar, and low inter-cluster similarity, which is basically items from different clusters are not very similar. So clustering analysis itself is obviously not one specific algorithm, but it's a general problem, right? Clustering is not like decision tree. Decision tree was basically where this particular algorithm where you had kind of, you were basically building out trees to separate out your positive and negative instances. That is not the case with clustering. In case clustering is a concept. It's not an algorithm. First to start up, it's basically the concept is that you separate your data into multiple clusters. Now obviously there could be various algorithms to do that, and that's the exact job of me to kind of teach you what are the different algorithms that could be possible. So that's what we are going to learn today. So don't worry about that part. So now let's look at some of the use cases of clustering. So we understand what is clustering. So let's now look at some of the use cases why clustering we would do. So one of the major use cases that kind of comes into top of my mind is basically for marketing segmentation, right? So you say you are a bank or you are a product company and you have got this new thing that is going to come out, right? And instead of sending every customer, every person in your database the same mail, you probably want to kind of customize this mail depending on the kind of people there. So to do that, you would want to kind of segment them into different buckets, and for each bucket you're going to have a different kind of the way you send the mail would be different from different buckets, right? But how do you separate customers into different buckets? That's the point, right? That's exactly the place where clustering comes into part, because this is not like supervised learning that you kind of have all the features of all the customers and then you have a column which says, yeah, this guy is like bucket 1, this is by bucket 2, this is bucket 3. You don't have that data, right? No one has annotated that data. So in that case, when you do not have any label data, right, that this guy belongs to people who love tech, this guy belongs to people who love sports, and this guy belongs to people who love politics. So if you don't have that kind of a different bucketing of the things, then it's probably very tough for you to kind of do supervised learning, because if you have to do supervised, you have to manually mark each of the customers to which bucket they belong to and then do the supervised training. Clustering solves the problem. You don't need all of those labeling data. All you're going to do is just look at the X, and based on what they kind of have interacted and all the features they are going to have, you're going to classify them into different groups. Not classify, you're going to cluster them into different groups. So each group is basically going to consist of people who are very similar to each other. And once you figure out what is the similarity between them, what is basically the basis of similarity between them, you're going to have a mail which just addresses them. So that's customer segmentation. Then basically the other kind of very relevant idea is the idea of clustering web pages, right, based on their content. So you basically say you're a newspaper company, and you every day there are so many articles that kind of goes out of your gets published on your newspaper. Now somehow you want to kind of tag them with say some tag like sports, tech. Within sports, you also want to tag them like cricket, basketball, football, and all of that. So you want to kind of do all of that tagging, because all this while you did not have anyone do that tagging, right? And one way is obviously you go manually tag all of them, and you need a lot of time to do all your articles that you've ever written, right? So that's going to be extremely tough. So what you do is you kind of take the content of the articles and basically compute some features from them, and based on those features you say that okay, based on these features it seems that these 5 articles are very similar, and you figure out that similarity is probably sports, and then you figure out another 10 articles which are extremely similar, and you figure out those 10 articles about say politics. So that's the way clustering works, right? So this whole point where you have a feature data, and then based on those feature data you kind of figure out which are the news items which are very similar to that. That is a process which is called clustering, and clustering is again very relevant when it comes to things like this, right? Clustering web pages, documents, newspaper articles, lot of anything that you can want to make groupings of, right? Customer segments, whatever you want to kind of group into, any kind of task that requires grouping without knowing the label data, which is basically what group they belong to. So unsupervised learning, just using the features, is what clustering is extremely useful for. So again, I have already talked about all of this. So clustering now comes in 2 major categories, and let's try and understand that. So understanding that is extremely important. Okay. Yeah, so also applications of clustering comes in supervised machine learning. This is something that we also need to talk about, which is, if you remember, in case of outlier detection, we had talked about multivariate outlier detection, and we had talked about clustering as one of the ways, right? So now think about this, right? Because as of now, when we are talking about outlier detection, we are talking always at looking at one particular feature, seeing if it's an outlier in that particular feature or not, and that's how we detect outlier, right? Every feature you look and you see which data point is an outlier. And that's pretty crude, right? Because you're looking at each feature at a time. What better could be that, right? You look at all the features together, and then you see which is the one which is an outlier, right? And that is the most interesting concept there, where clustering kind of comes into play, right? So clustering. So this is the example where we were using, right? So as of now. So as of now, when we were looking at clustering, we were basically seeing at one dimension. So in this particular dimension, you would see that these 3 points are the ones which are probably outlier, right? Because this is the 0.7. This is basically quartile Q3 plus 1.75, say whatever the Q3 minus Q1, right? So that is what is basically out here, right? So this is the point where it is. You detect that in this particular feature, right? So this is one particular feature. In terms of this feature you see, and in terms of this feature you see that this is the point which is outlier. So as of now, we can only do it in each feature. We look at it independently and figure out which are the points. With clustering, what you can do is you have the same data, and then you have something like this, and then you have something like this. So what you can do is you can very easily see that these 2 points are probably very similar to this. So you can put all of them in one particular cluster, and this is one thing which is a different cluster, and you can see that this cluster, just as one example, which probably means that this cluster is an outlier. So clustering is obviously one of the major use cases of doing multivariate outlier detection, because as you can clearly see here that if you do this multiple outlier, if you do outlier detection using clustering, so you can do in multiple features, right? Earlier you were just looking at one feature at a time. Now you can look at all the features at one single go, and based on all the features you can basically take a call whether which point is an outlier. So that is probably much more accurate than looking at each variable individually, right? Because when you look at combination of all of the features, you clearly see that this is the only point which is an outlier, right? The rest of the points are perfectly fine. Which is something you would not be able to do if you were doing just one variable outlier detection. So that's the concept of using clustering for outlier detection. There are so many other things where you can use it for. So once you kind of get an idea of what clustering does and how it works just with X, you can basically use that for different ways of feature reduction, feature engineering, whatever you want to do with just the X values. So in supervised learning, you have the X as well as the Y, right? So anything you do with the X is something that we call unsupervised learning, and one of the examples is clustering. So anything that you do with the X in unsupervised learning, you can do the same things in X in supervised learning as well, right? So you generate new features to do outlier detection, the same kind of things you can use there also, because the X is still common in supervised as well as unsupervised. It's the Y that is not there in unsupervised learning, right? So clustering is something that you can find a lot of use cases for that. So now we are going to talk about clustering and the different ideas behind clustering. So there are two major ideas, the two major, I would say, ways, not two, but there are actually more. In this lecture we are going to talk about just two. So the two major concepts that we are going to cover about clustering is something called flat or partitional clustering, and the other idea is called hierarchical clustering. So first, let's understand what is flat or partitional clustering. So flat or partitional clustering is something that we are familiar with, which is basically given a set of news articles. We are going to classify them into sports, tech, politics, entertainment, right? So you have got this whole. So these are your news articles, right? So these are your different news articles that you can probably think of. And what you do is basically figure out that there are different, so this is one cluster, this is one cluster, and this is probably another cluster. So these are your sports articles, these are your tech articles, and these are your political or entertainment, whatever, and this is the third cluster, right? So there are three different clusters in your all the news articles that exist, and you kind of separate your news articles into these three distinct clusters such that there's no overlap between clusters and all of that. So this is a concept, this is a conventional idea of clustering that you're familiar with, right? So you have got news articles, you separate them into different buckets. Each bucket is completely separate from the other bucket. There's no overlap between them and everything. It's completely neat and very clearly easy to understand, right? So you have got each article which can either belong to sports, or it can belong to tech, or it can belong to politics, right? And there's no relationship between these clusters, right? This is nothing like one cluster is subset of other cluster and something of that sort. So that is the concept of flat or partitional clustering. Easy, conventional thing, right? You have got articles, you group them into different buckets. Now the second idea is called hierarchical clustering. Hierarchical clustering is slightly developed, which is basically now you have got news articles. You obviously want to kind of do that whole thing of separating them into tech, sports, and say entertainment. Now in sports you also want to kind of separate them out into whether it belongs to basketball, it belongs to cricket, or it belongs to football. Within cricket you also want to separate out whether it belongs to IPL, whether it belongs to World Cup, whether it belongs to something else, probably whether it belongs to ODI, whether it belongs to T20, whether it belongs to Test. So you want to do all of that kind of separation, right? So that's the concept of hierarchical clustering. So hierarchical clustering, as the name already suggests, that there's a broad cluster which is all news articles. You separate that into clusters which are beneath it, which is sports, tech, politics, and then sports is also divided into multiple categories. Tech is also divided into multiple categories, and so basically the sports, the different cluster that comes under sports, say cricket, basketball, volleyball. So these are all clusters of cricket, basketball, and volleyball are basically subset of the cluster of sports, and sports, tech, and politics are basically subset of the cluster which is the all news cluster, right? All news are basically the biggest cluster, and within that you have got segments of this sports, tech, and politics, and sports also comes in the different three versions, and so on and so forth, right? Individually basketball, cricket ball can also be broken, they can be further broken down, And that's the concept of hierarchical clustering. So there's a hierarchy, there's a sort of ordering between your different clusters, as you can clearly see in this case. So you kind of keep on doing this hierarchy. The only thing is basically you keep on doing this hierarchy till you reach the point where each individual news article is a single cluster in themselves, right? So that's the idea. You start from top and you kind of do this whole bucketing till you reach the point where you're left with just individual articles as single point clusters. Those are called singleton clusters. So each of the singleton clusters basically combine to form a big cluster, which again combines with another big cluster to form another bigger cluster. Bigger cluster forms with another bigger cluster to form the biggest cluster, right? So there are different levels to this clustering problem, and that's the concept of hierarchical clustering. So in this particular case, you can clearly see this explained through this diagram. This is called a dendrogram or something. We'll probably, this is called dendrogram, right? So here in this case, in case of flat or partitional clustering, you have to say how many buckets you want to divide into. So you want to say how many, so if you are doing market segmentation, you want to say how many segments of customers do you want to separate into. So in case of articles, you have to say I want to separate into 3 buckets: sports, tech and politics. In this case, you don't have to say that, because the whole goal of this algorithm is basically to get a hierarchy of different things, and based on what is the resolution you want to look at, what is the granularity you want to look at, you will have as many clusters. If you just want to look at sports, tech, politics kind of a level, you would have 3 clusters. But if you want to look at further level, you would probably have 15 clusters. So 5 from sports, 5 from tech, 5 from, so depending on the level that you want to look at, you would have as many clusters as you can. And now you look at this concept, so it's pretty easy to understand. So you can clearly see here, cluster 1 and cluster 3 are basically so at the bottommost level, all of these points are basically one single clusters, right? All of these ones that you see in black dot are basically the single point clusters. Now you can see here from the image as well as from the dendrogram that 1 and 3 are combined to form a new cluster, which is a cluster marked as 1 in red, right? So the cluster 1 in red 1 is basically the cluster which contains points 1 and points 3. And then points 1 and 3 combined with this bigger cluster. So also apart from that, point number 2 and point number 5 combine to form this cluster in red 2. So red 2 cluster is basically points 5 and 2. That combines with point 4 to form the cluster which is red 3. Red 3 combines with red 1 to form cluster red 4. And red 4 and point 6 combine to form a cluster 5, right? So that's the idea of hierarchical clustering. So you have got at the most basic level, you have got each of these points as single points, and then you kind of club them, and then you club the cluster with some other point, or you club the cluster with another cluster. You can just kind of go on clubbing whatever you want to, and then you have this whole thing, which is the entire data set. The entire data set is basically here, right? So this whole data set, this whole largest circle outside, right, the one which is cluster red 5. So red 5 is basically everything, and within red 5 you have, if you now go split it down, you see red 5 consists of 0.6 and another cluster. That cluster consists in turn of 2 more clusters. Those two cluster, one consists of points, and so on and so forth. So there's a hierarchy between the different points that are there in the group, right? And that's the concept of hierarchical clustering. So now that we understand some bit of clustering, what is it important for? What are the different techniques? Now let's go and understand the first technique, which is the partitional clustering, and that is the most important algorithm that is there for partition clustering. Is called k-means, widely used, fantastic, very popular. Let's understand that now.
Log on to GreyAtom's learning platform to unlock more free content. Subscribe to our channel and hit the bell icon for regular updates.